Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss all about heat engine. Let's begin. Heat engine, that is the conversion of heat into mechanical work, means that heat engine converts heat into mechanical work. Heat engine is a device which converts heat energy into mechanical energy. Some examples of heat engine are petrol engine in some bikes you can see petrol engine, diesel engine, some cars you see it diesel engines, and steam engines. These are the examples of heat engines, means they convert heat energy into mechanical energy. Now we study about what is the principle and working procedure on the basis of which heat energy converts into mechanical energy in case of heat engine. So, the principle of heat engine means, according to the principle of heat engine, a system whose different parts are at different temperatures. Different parts are at different temperatures tend to move towards the state of thermal equilibrium. Means the parts of that heat engine, different parts, there are three parts of heat engine generally we introduce. One is source, working substance and sink. These three parts are basically denoted according to their temperatures, and on the basis of their temperatures they tend to the state of thermal equilibrium, and on that particular way the heat engine works. We have to discuss the parts of that heat engine one by one. First part, that is source. What is source of heat engine? It is a hot body. It is a hot body maintained at a constant temperature. Maintained at a constant temperature, let T1. It has very large thermal capacity. It has very large thermal capacity. Such that, why we need large thermal capacity? Such that if certain amount of heat is taken out from that of source, taken out from that of source, its temperature should remain unchanged. Source, its temperature should remain unchanged. See, what is that source? it is a hot body maintained at a constant temperature T1. Why we maintain that of constant temperature T1 means it is the higher temperature as comparison to that of sink. We discuss sink later. So, why very large thermal capacity that source has means if certain amount of heat is taken out from that of source, its temperature should remain unchanged. That is why we take a large thermal capacity, means the temperature of that of source is too high. Second part of that heat engine, that is sink. What is sink? It is a cold body. This is a hot body, that is a cold body. It is a cold body. Cold body in the sense that maintained at a constant lower temperature. Constant, this is a constant high temperature, constant high temperature T1. Here is a constant low temperature, constant lower temperature T2. Okay, and it absorbs the rejected heat from that of source, sorry, it absorbs that of rejected heat, from which the rejected heat then we studied. Now, it has very large thermal capacity also like that of source. It has very large thermal capacity such that same method, such that if certain amount of heat is given to that of sink, its temperature should remain unchanged, Okay. Source is a hot body maintained at a constant temperature, that is high temperature T1. Sink is the cold body that maintained at lower temperature T2. Almost same thing, that is the high temperature, that is the low temperature. Next, third one, that is the working substance. That is the working substance. Working substance means a material, basically used a material which absorbs heat energy from source and rejects a part of this heat, to sink and convert the remaining one and convert the remaining heat energy into mechanical work. These three are the different parts of that heat engine. These three are worked under the principle of thermal equilibrium. So, let me construct how these three are arranged in a heat engine. So, here is the source, that is the source. This is the working substance here. Here is the sink. Let me take it. This is the source which is at a temperature T1. That is the working substance. Here these are the working substance, and that is the sink at a temperature of T2. How all these are taken, we have to discuss through in that of working procedure. So, these are the three different parts of that of heat engine: source, sink and working substance. Now, what is the working procedures? On the basis the heat engine works, what is that of working procedure? In every heat engine, the working substance absorbs some heat from that of source. That working substance, here is the working substance that absorbs some amount of heat from that of source, rejects a part of this heat to sink and converts the remaining into useful work and returns to initial state in the cyclic process. Some amount of heat absorbs that working substance and rejects some part to that of sink, and remaining parts are converts into doing some useful work, and that process is carried out in a cyclic manner, and a continuous mechanical energy is obtained from the heat engine due to the repetition of same cyclic process again and again. First one cyclic process occurred, some amount of work is done, another cyclic process, another work is done. Similarly, the repetition of continuous mechanical energy is created due to that of cyclic process. Now, let me mathematically introduce how exactly the work is done in case of that heat engine. So, let amount of heat absorbed, heat absorbed by the working substance from the source, at temperature T1. that is Q1 amount of heat absorbed. Here is the Q1 amount of heat. Okay. Now heat rejected by, here heat rejected by working substance, heat rejected by working substance to the sink at temperature T2 is equal to Q2. Heat rejected to that of working substance to that of sink will be Q2. Now the net amount of heat absorbed, then the net amount of heat absorbed that is, let dq is the q1 minus q2, that is the net amount of heat absorbed. Now let the initial internal energy of that working substance be ui. Let initial internal energy of working substance is, let ui, initial internal energy of that working substance ui, and final internal energy of working substance, let uf, that is the final internal energy of that working substance. Since during each cycle the working substance returns to its initial state, so since each cycle the working substance returns to its initial state, hence change in internal energy, will be what? Will be 0. That means we can write here what happened, u final minus u initial will be 0. Therefore, let work done by heat energy during each cycle is equal to W. Let work done by heat engine during each cycle is equal to W. Therefore, according to first law of thermodynamics, what happened? According to first law of thermodynamics, the amount of heat supplied, that is du plus dw, change in internal energy plus work done. Here change in internal energy will be 0, that means dq is equal to 0 plus dw, and dq is the change in heat, that is q1 minus q2, that is q1 minus q2 is equal to, here that is not dW, that is W, that is the total work done is the, as we studied here, in each cycle the work done is W. So that is W, Q1 minus Q2 is equal to W, since dQ is equal to Q1 minus Q2. So the work done is Q1 minus Q2, that the work done. Here I write the work done, here is the work done, W is equal to Q1 minus Q2. Source at temperature T1 rejects the heat Q1, sink at temperature T2 rejects the heat Q2, and the work efficiency, sorry, that is the work done, that is Q1 minus Q2, the difference in heat. This is the working thing in that of heat engine. Now what should be the efficiency of heat engine? The efficiency of heat engine, that is denoted by eta. What is efficiency? Any kind of efficiency means how much amount of work is done of that a particular device due to some amount of input. What is the output to that of input? So the ratio of output to input is the efficiency. So in that of case of heat engine, it is defined as the ratio of work done, W by heat engine during each cycle, to the amount of heat absorbed, from the source, that is at Q1, source Q1 by that working substance, by the working substance. So generally we say the efficiency, therefore the efficiency is equal to work done divided by heat absorbed, as I saying that before, that is the output to input. This is the input, means heat absorbed with the input. As far as heat absorbed is concerned, so that leads to some kind of work done. The ratio of work done to that of heat absorbed is the efficiency. Therefore the efficiency eta is equal to work done W divided by heat absorbed, that is the Q1 amount of heat absorbed, or eta is equal to W, that is the Q1 minus Q2, that is the Q1 minus Q2 divided by Q1, or eta is equal to Q1 by Q1 minus Q2 by Q1, or eta is equal to 1 minus Q2 by Q1. Eta is equal to 1 minus Q2 by Q1. Since Q2 is always less than Q1, as we know the sink, Q2 is always less than Q1. Q2 is less than Q1 means that overall quantity is less than from 1. So that eta, that is we can write here, that is eta, here Q2 is less than Q1, therefore it leads to that eta, means that term is less than 1 minus something, that is less than 1. So eta is less than 1, means efficiency of a heat engine is always less than 100%. Therefore hence efficiency of a heat engine is always less than 100%. Again, if we put Q2 is equal to 0, just a condition, if Q2 is equal to 0, then eta will be 1, means we get 100% efficiency of that particular heat engine, but actually that is not possible. Which is not possible? Practically that is not possible to get 100% efficiency of heat engine, which is in theoretical purpose we say it as ideal heat engine. If we take into consideration that is ideal one, means we get 100% efficiency for that of heat engine. So with the help of this video lecture we understand what is heat engine, principle of heat engine, and some parts: source, sink, working substance, and how heat engine works, the working method of heat engine, and some mathematical way to describe what exact amount of work is done in that of heat engine. This is the mathematical way to get the work done in a heat engine. And finally the efficiency of heat engine, we take the efficiency of that heat engine. So with this useful and informative notes, let me wind up this session. Thank you.